Right, we just now did this question. 45 raised by n minus 23 raised by n minus 24 raised by n plus 79 raised by n. Right? Basically, you found the remainder when it is divided by 77. The answer turns out to be 0. Now, I am giving you a new question. Now, the question is, prove that this is divisible by 77, because you know that is true, by the method of factorization. Because come on, see, x raised by n minus y raised by n, factors. Using factorization method, prove that this quantity is divisible by 77. Do that. We already discussed factorization in polynomials and equations extensively. सबसे पहले तो फॉर्मूला याद होना चाहिए, right? Now I know that x raised by n minus y raised by n is nothing but x minus y into x raised by n minus 1 plus x raised by n minus 2 into y plus x raised by n minus 3 into y square plus so on plus y raised by n minus 1. Right? Now I need to prove that this is divisible by 77. That means it should be divisible by 11 as well as 7. So let me check step by step. Let me prove that this is divisible by 11. So that means when I find the factors, 11 should cross. 11 चाहिए. अब देखिए इन दोनों का डिफरेंस क्या है? 22. Oh, right? 45 and 23, that is 22. Because x minus y चाहिए होगा, right? And इन दोनों का डिफरेंस चेक करें. 79 minus 24, that is 55. Again, a nice number. So I'll combine these two and then these two. So 45 raised by n minus 23 raised by n plus 79 raised by n minus 24 raised by n. Now x raised by n minus y raised by n. Factors is x minus y. So 45 minus 23. Right? Into some, whatever the case may be, I am not interested. Why? Because it's an integer. Right? Definitely this will be an integer. Now plus. Now this is x raised by n minus y raised by n. Factors are x minus y. So 79 minus 24. Into something, whatever the case may be, it will be an integer. Right? Now this is 22 into some integer, let that be k, plus 55 into some integer, let that be n. Now from here I have 11 common. Right? Since this is 11 into some integer, I can say that this is exactly divisible by 11. Now, sorry, this is done by 11. Now let's talk about 7. Right, so again write down. So 45 raised by n minus 23 raised by n plus 79 raised by n minus 24 raised by n. अब मुझे चाहिए divisibility by what? 7, right? So यहाँ से difference है 22, no, इन दोनों को तो नहीं जाएगी, इन दोनों को देखें. Then we combine these two. Difference 45 minus 24, that is 21. A nice number. So combine these two. So 45 raised by n minus 24 raised by n plus 79 raised by n minus 23 raised by n. Right? Again, x raised by n minus y raised by n. So x minus y. So 45 minus 24 into some integer plus x raised by n minus y raised by n. So factors x minus y into some integer. Right? Now this is nothing but 21 into m, this is m plus this is what? 56 plus यहाँ पे क्या करें? ऊपर. Right? I can see that I can get 7 common. 7 into some integer. Now this is expressed as 7 into some integer. I can say that this is exactly divisible by 7. So this is divisible by 11 as well as 7. That means definitely it is divisible by 77. You can use factorization also, a very important technique in number theory. Right? Now let's see whether you've understood this or not. Write down the next one. Prove that 3 raised power 6n minus 2 raised power 6n is divisible by 35. Prove that this is divisible by 35 for any integer n greater than 0. So any positive integer basically. Come on. So these pretty factors. एक तो वैसे दिख जाने चाहिए. Come on. 3 raised to 6n minus 2 raised to 6n. It's so tempting to write this as 3 raised to 3n square minus 2 raised to 3n square. Right? Because x square minus y square. The easiest factors that we know. So this is nothing but x minus y. So 3 raised to 3n minus 2 raised to 3n into x plus y 3 raised to 3n plus 2 raised to 3n. Right? Now 3 raised to 3n is specifically 27 raised to n minus specifically 8 raised to n into 27 raised to n plus 8 raised to n. Right? Now I want divisibility by 35. So if you look closely, 27 plus 8 which is 35. अब तुम बोलोगे मैम ये तो ऐसा कुछ पढ़ा हुआ है हमने फैक्टराइजेशन में. डू यू रिमेम्बर? x raised to n plus y raised to n can be factorized as x plus y into x raised to n minus 1 minus x raised to x minus 2 into y plus last quantity will be minus y raised to n minus 1 plus होता. Right? Remember this? But there was a big condition. This can only be applied when n is a odd number. N is odd over here. Remember? X cube plus y cube or x raised to 5 plus y raised to 5. N has to be odd. So from here, I can get 35 easily because if n here is odd. Right? Let me consider this. So n is odd. That means it is of the form 2k plus 1. Right? So this becomes 27 raised to n minus 8 raised to n. यहाँ पे actually 2k plus 1 ही लिख लो है ना? Better. Now replace n by 2k plus 1 because it is odd and I want to highlight it. So 27 raised to 2k plus 1 minus 8 raised to 2k plus 1 into 27 raised to 2k plus 1 plus 8 raised to 2k plus 1. Now I know that this is odd. So that means I can factorize it like that. So this is nothing but 27 plus 8 into some quantity which will definitely be an integer. Right? Now 27 plus 8, इससे पहले ये भी quantity है, don't forget that. 27 plus 8, that is 35. So basically this quantity gets reduced to 35 into some integer. So yes, this quantity is divisible by 35. But under a big condition that n is equal to 2k plus 1 where n is odd. So you might say, ma'am, what if n is even? Absolutely right. We have to consider that case. The first case is this. Second case is n is even. N is of the form 2k. Right? When n is of the form 2k, so let's see what happens. So this is 27 raised to 2k minus 8 raised to 2k. Into 27 raised to 2k plus 8 raised to 2k. Right? Now again, I can write this as, because factors पता होता है मुझे इससे. That's why. Right? Now a square minus b square, so a minus b. So 27k minus 8k into 27k plus 8k into 27 raised to 2k plus 8 raised to 2k. As it is. Right? Now you want divisibility by 35. Again you have this 27 raised to k plus 8 raised to k. Right? But again the condition is that n has to be odd. Now you will say, ma'am, we don't know anything about k. It might be odd or it might be even. But if k is odd, I'll get one of the factors as 27 plus 8 which is 35. Right? If k is odd, I have proven that the number is divisible by 35. Right? But now you will say, ma'am, what if k is even? Absolutely fine. Again, what you will do is you will substitute k as अब तुमने क्या पुट करना है 2 n नहीं पुट करना 2f. right? Substitute it. So you get 27 raised power 2n minus 8 raised power 2n into 27 raised power 2n plus 8 raised power 2n into this quantity, right? Again, इसके factors कैसे बनेंगे? Right? Because कैसे लिखेंगे? M square and then M square. A square minus B square. So again I can write A minus B into A plus B into this quantity, which I am not writing it. Right? Now again this thing is there. Now I can get 35 if M is odd. Right? Now you see now M odd के लिए तो फिर हो गया हमारा, but what if it is even? Then I say do this step again. Now you say, ma'am, will this process end? Definitely this process will end. Right? Because ultimately I will get the powers of 2 outside. जितना भी even है n में last thing. If I take out all the factors of 2 outside, ultimately I will be left with an odd number. Right? Maybe after 2 steps, maybe after 3 steps, maybe it will take me 10 steps. Maybe 2 raised power 10 is there, right? It will take me 10 steps to take out 2 common. दोबारा से करूँगी, right? But at the end, I will be left with the odd number. Right? Now, if odd number is there, definitely my factor will be 27 plus 8, which will be 35. So, do we understand the nuance of this proof? I'm giving you 10 seconds, just revise it. Revise it. It is very important to know how to write such kind of proof. Come on, revise it. Done? Okay, let's see. If you have understood this question, let's see whether you get the next one or not. Write all positive integers n, all positive integers n such that 20 raised power n plus 16 raised power n minus 3 raised power n minus 1 is such that this is divisible by 323. Come on. Write all positive integers n such that this is divisible by 323. Come on, hurry up. Now 323 is a very good number. Right? First of all, try to find the factorization, which is 17 into 9. Right? Okay, 17 into 9. If I am able to prove that this quantity is divisible by 19 and 17, I can say that this is divisible by 323. So let me talk about 19 first. Right? I want to see whether this I want to find out those n for which this quantity is divisible by 19. Right? Ultimately मुझे factors बनाने हैं. अब देख रहे हैं 19 कैसे generate होता है. 20 difference multiply वैसे क्या करूँगी मैं, right? 23 difference is 17, no, 21. Okay, so that means difference here is 19. So I'll combine these two and these two. 20 raised power n minus 1 plus 16 raised power n minus 3 raised power n. Right? Now this is x raised power n minus 5 raised power n. That is not an issue. This is x minus 5 into the quantity that we know. So मैं आता लिखना, right? From here I can factorize this. This is 20 minus 1 into something plus. Now here I want to get what? I want to get 90 here from itself. यहाँ से 19 आना चाहिए। अब 19 कैसे निकालें, दैट इज अ प्रॉब्लम। 19 कैसे निकालें, अब यहाँ पे तो आ गया 19। अब यहाँ से 19 निकालने के लिए मुझे देखना पड़ेगा whether it's an even or odd number, right? So n, let me talk about when n is even. When n is of the form 2k. So from here 19 into some integer plus this is 16 raised power 2k minus 3 raised power 2k. Right? Again I can write this as 16 raised power k whole square minus 3 raised power k whole square. A square minus b square, right? Factors बनते हैं उसके 19 into something plus factors 16 raised power k minus 3 raised power k into 16 raised power k plus 3 raised power k, right? Okay. From here I can get 19, right? But you say ma'am ये odd होना चाहिए, but as we just discussed that इससे अगर odd नहीं है, again मैं cases बनाऊंगी. Ultimately what I'll do is I will get powers of 2 out. I'll get the factors of 2 out. And ultimately I'll be left with the odd number. Right? And ultimately if I'm left with the odd number, that means I'll get a factor of 19. Right? Okay. So that means from here I can get the factor of 19 easily. So when n is of the form 2k, where n is even, definitely I'm getting the factor of 20. Right? I wanted all those n such that this is divisible by this. For even numbers, I am getting that this is divisible by 19. Now, if somehow I can say that for even integers, this is also divisible by 17, my problem is solved. Right? So, let me check. For even integers, let n is equal to 2k, whether this quantity, 20 raised power n की जगह 2k लिखिए, 2k minus 6 plus 16 raised power 2k minus 3 raised power 2k minus 1. Whether this quantity is divisible by 17 or not, that I need to check now. वो check करना. अब 17 definitely. Let me combine these two, right? And obviously I will be left with these two. So this is 20 raised power 2k minus 3 raised power 2k plus 16 raised power 2k minus obviously 1 को मैं लिख सकते हैं 1 raised power 2k. Right? Factors, इसको बस लिखने के लिए भी ऐसे लिखते थे. We have done that so many times now. Right? A square minus b square, so a minus b into a plus b. Into a plus b. Plus, अब again इसको ऐसे लिख लेते हैं. Right? So this is 16 raised power k minus 1 raised power k या minus 1 ही लिख दूं into 16 raised power k plus 1. Right? From here definitely I am getting the factor of 17 common. So 17 into some integer plus. Now from here I can get 17 common provided k is odd. As I said, even if k is even, I can make the cases and at the end I will get an odd number. Right? If at the end I am getting the odd number, that means I am getting this the factor of 16 plus 1 into some integer, and we don't care about the integer. Right? So that definitely 17 common. So 17 into some integer. That means for n is equal to 2k, I can get this divisible by 17. Now when n is even, this is divisible by 19 as well as 17. That means when n is even, the quantity is divisible by 323. When n is even. Now, all the numbers लिखते हैं, that means n might be of the form 2, 4, 6, 8 and so on. Set of even integers, even positive integers. Right? Okay, now the next one. Next is the number prime or composite. So my number is 4 raised power 545 plus 545 raised power 4. You need to tell me whether this number is prime or composite and you need to justify it. Obviously, I mean. Come on. First of all, just calculate this quantity and let's see whether it's prime or composite, and then justify it. Come on. What is that we are doing in this part of the lecture? What are we doing? What are we basically discussing? Factorization. Right? Now, prime and composite. Now, I know that a prime number should not have any factors except for 1 and the number itself, right? But composite might have other factors. And lecture में factorization there. If somehow I am able to factorize this quantity, I can say that it is composite. And if I am not able to, then I have to see what I can say. Right? But look carefully. I think we can factorize it. Just look at it. Such a nice number, 545. Oh, 545. 545 directly, obviously 4 से तो divisible नहीं है. 544 है, right? ठीक है. 544 is divisible by 4. What I'll do is I'll write this as it is. 545 raised by 4 plus. अब 4 चाहिए यहाँ पे. What I'll do is I'll take 1 4 common. 4 not common. I'll take 4 out. So 4 into 4 raised by 544. So you will be perplexed. Then why suddenly you are doing it? Right. Very valid question. Factorization करिए नहीं लिखा गया है. Right. Okay. So सबसे पहले तो 545 is near to 4. So मैंने इसको ऐसे लिख लिया. Right. अब आगे क्या करें? अब ये 4 साइड में आ गया. Okay. What I can do is I can consider 545 as x. Because if I look at the quantity as it is, I can factorize it. Polynomials to factorize करने में we know formulas, right? I can easily factorize polynomials rather than these quantities, right? So let me just convert it into a polynomial. Maybe I can see what factors are there, right? So I'll write this as x raised to 4 plus a 4 as it is into. Now what I can do is अब यहाँ पे x raised to 4 है ना, अब इसको ऐसे लिख लो y raised to 4. Because this number is divisible by 4 now. So इसको ऐसे लिख लेते हैं. 4 से कैसे divisible है? 5 raised to 4 चाहिए ना ultimately मुझे. So 1, 12, so 3 and 24, 6. Hopefully यही आया. Right? So y को मैंने ये put कर दिया. So basically my polynomial is this. बोलोगे ma'am, how can you factorize this polynomial? We have done this factorization quite a lot of times. Come on people. X raised to 4 plus y raised to 4. Squared quantities हैं, right? X square whole square plus 4 special that 2y square whole square. Complete the square, right? Completing it square again. A square plus b square plus 2ab. So 2 into a is x square into b, which is 2y square. Up plus 2ab minus 2ab by itself, so minus 4 x square y square. Right? Now I've completed the square. This is nothing but x square plus 2y square whole square minus 4x square y square. अब factors बनाने हैं. A square minus अब ये b square नहीं. I can write this as 2xy whole square. A square minus b square. Factors a minus b into a plus b. Come on. X square plus 2y square minus 2x square into x square plus 2y square plus 2x square. This number has been factorized like this. Now clearly I can say that this is not 1 and this is not 1. So I have factorized this as product of two factors other than 1 and the number itself. So I have factors other than 1 and the number itself. That means this number is composite. Right? Factorization, class 9, polynomials. Come on people, we have done this. We have done this particular factorization in class. Right? Okay. Now, the next one, which is a very interesting question. You'll definitely enjoy, so write down. Prove that the numbers prove that the numbers Fn, numbers have been defined as this, Fn equal to 2 raised power 2 raised power n plus 1. 2 raised power 2 raised power n, right? So, prove that the numbers this, where n is equal to 0, 1, 2, 3 and so on. Prove that these numbers are pairwise co-prime. Pairwise co-prime. Come on. First of all, understand it. I'm giving you 5 seconds just to understand what he is trying to say. Come on. Numbers. Now, first of all, numbers कैसे मिलेंगे जब मैं n को यहाँ पे values put करूँगी. So पहले values put करके देखते हैं. Then let's see what happens. So n can be 0. So f0 निकालते हैं. f0 is replace n by 0. So replace n by 0. So 2 raised power 0 plus 1. Right? अब ये quantity लिखनी है. अब 2 raised power 0 is 1. Right? 2 raised power 1 2 plus 1 which is 3. Then let's talk about f1. Replace n by 1. N by 1. So 2 raised power 2 raised power 1 plus 1. Now 2 raised power 2. Right? So this is 4 plus 1 which is 5. Then let's talk about f2. So 2 raised power 2 plus 1. Now 2 raised power 4 which is 16 plus 1 which is 17. Okay. Now let's take one more so that I can easily see. F3. So 2 raised power 3 plus 1. So this is 2 raised power 8 which is 256. 256 plus 1 257. Right? So you can give the values to n and you'll get the numbers. Numbers are 3, 5, 17, 257. He says that you need to prove that these numbers are pairwise co-prime. Now first of all, my numbers turn out to be 3, 5, 17, 257 and so on. Right? Pairwise co-prime. That means if I take 3 and 5, they should be co-prime. Co-prime as in they should not have a common factor greater than 1. As in HCF is 1. Right? Okay. If I take these two, HCF should be 1. If I take these two, HCF should be 1. If I take these two, HCF should be 1. Pairwise co-prime. If you take out any two numbers, those should be co-prime. You need to prove that. Right? अब the question समझ रहे हैं. We're trying to understand what is he asking us. Right? Okay. अभी तो ये analysis किया. We are trying to understand. Now, obviously, since I have to prove something, I cannot take just 5 examples. I have to prove it. So I have to move in a very general fashion. Right? So, obviously, I will have many numbers. So f0 will be there, f1 is there, f2 is there, so on. I will have fn. Right? He says if you pick out any two numbers out of this, they should be co-prime. Right? So what I'll do is I'll take out this number, fn, and if I जाके मेरे पास fm आएगा. If I am able to prove that these two arbitrary numbers, if these two arbitrary numbers are co-prime to each other, my question is done. There's arbitrary elements there. Right? So let me take fn and fm where I am assuming that fm is greater than fn. Right? Okay. So consider fm. fm क्या होगा? fm is 2 raised power m plus 1 and fn will be 2 raised power n plus 1. Right? I need to prove that these two are co-prime. That means the HCF should be 1. Right? Okay. HCF is 1. अगर मैंने prove कर दिया that their HCF is 1, my problem is solved. ठीक है? So let me consider the HCF of these two numbers. Consider कर लेते हैं that the HCF of these two numbers is D. Right? Basically, I need to prove that D is 1. Right. Okay, suppose कर लिया. अब D को 1 prove कैसे करें? Or how should we begin the problem? Till now we've just analyzed it. We have not begun the question. How should I begin it? We obviously want to relate fn and fn somehow. We want to relate that. ठीक है, अभी तक इस पार्ट में हमने किया क्या है, फैक्टराइजेशन. नाउ द प्रॉब्लम इज फैक्टराइजेशन यहाँ पे +1 है एंड डेफिनेटली दिस इज एन इवन क्वांटिटी, राइट, और नहीं है, तो इसकी फैक्टराइजेशन तो नहीं हो सकते. अगर यहाँ पे -1 होता तो हो जाती है ना फैक्टराइजेशन, +1 है, दैट इज द प्रॉब्लम. अब फैक्टराइजेशन करनी है, यहाँ पे -1 होना चाहिए. So consider sn -2. Consider this number instead of this, right? Because maybe I'll be able to factorize this. This is nothing but 2 raised power m of +1 -2, so I can say -1. Now since minus is here, that means I can factorize it. Maybe not, but we'll see. At least I have that option in me, right? So I am here. But the problem is, how should we proceed? So ultimately, I want a clear-cut relation between Fm and Fn. So somehow, यहाँ पे तो ऐसा करना पड़ेगा कि Fm जनरेट हो जाए राइट हैंड साइड पे. अब Fn जनरेट करने के लिए I want 2 raised power n. अब यहाँ पे तो 2 raised power 2 n. अच्छा ठीक है, क्या करें? Now you can say मैम, अब यहाँ पे 2 raised power n करना है. One thing you can do is you can write this as 2 raised power 2n, 2 raised power n, and इसके पावर में आप ले सकते हो 2, because इनके पावर्स ऐड करनी पड़ेंगी. So be careful, right? अगर ये मल्टीप्लाई होंगे, इनकी पावर्स ऐड हो जाएंगी और मुझे चाहिए होगा m - n. समझ आया? अभी मैं ये कर लूंगी, जैसे मैं इसे ओपन अप करूंगी ये मल्टीप्लाई होंगे, पार्ट्स मल्टीप्लाई होते हैं. अब पार्ट्स मल्टीप्लाई होंगी तो इनकी पार्ट्स ऐड हो जाएंगी, मेरे पास यही क्वांटिटी आ जाएगी एंड -1, राइट? ओके फाइन, वो मैंने कर लिया. अब उसके आगे करेंगे क्या? यहाँ पे द पॉइंट इज, अगर मुझे Fn क्रिएट करना है, मुझे यहाँ पे +1 चाहिए. अभी यहाँ पे -1 है. You know, this is problem to me. Sometimes I need +1, sometimes I need -1. Right? So I will not break it up like this. I'll break it in a very peculiar manner. Just look at it. Right? I'll break it up and then I'll give you 5 seconds to understand why I broke up in that manner. Right? So I will break this as 2 raised power n plus 1 to the power 2 raised power ये क्या बन जाएगा m minus n minus 1. वो तो मैंने obviously m बनाना है, तो but just think about it, why I wrote this part, why I have broken up in this manner. I'm giving you 5 seconds, just analyze it. Why? Come on. I think it is very clear. 2 raised power n plus 1. How is it related to 2 raised power n? This is nothing but, right? So basically what I can do is 2 raised power 2n whole square. राइट, ये 2 raised power n था ना, हाँ, इसका होल स्क्वायर. सॉरी यार, मैंने कुछ गलत कर दिया, ये मल्टीप्लाई नहीं होना चाहिए था. नो, ओके, या, सो डू यू अंडरस्टैंड इट व्हाट आई एम ट्राइंग टू डू? दिस पार्ट इज नथिंग बट द स्क्वायर ऑफ दिस थिंग. अगर मैं इसका स्क्वायर करूं, राइट, सिंस ये मल्टीप्लाई होंगे, इनकी पार्ट्स ऐड हो जाएंगे, दैट विल बी 2 raised power n plus 1. इसको ऐसे लिखना पड़ेगा, पहले बस 2 raised power n into the parts multiply with 2, right? Then their parts will be added and I'll get this quantity. This is nothing but the square of this quantity. Why is it complex now? I mean square to here. Why square? We want Fn and you are trying to get the square of it, right? Plus 1 है, हाँ, we'll deal with it. But we are trying to get Fn. आपने square कर दिया. Let's see what happens. Now, सबसे पहले तो यहाँ पे -1 है, इसको यूज करेंगे. So I'll write this as -1 raised power 2 raised power n minus n minus 1. वो तो जो मर्जी लिखो, right? Because obviously I will want to factorize it. So x raised by n minus y raised by n factorize करते हैं. So x minus 5, so 2 raised by n plus 1 minus 1 into some quantity which we don't care about, into some material, right? Right. Okay. अब क्या कर सकते हैं? Now, since मैंने square quantity बनाई थी, now I'll take advantage of it. This is nothing but 2 raised by 2 raised by n whole square, right? Power multiple, whole square minus 1 square. This I've written like this, down like this, into some integer. Just wait a second. You'll realize why this is nice. Now, a square minus b square. So again factors a minus b. So 2 raised by n minus 1 into 2 raised by n plus 1 into some integer. This quantity is this quantity SL. मुझे plus 1 चाहिए था, plus 1 यहाँ से मिला a plus b से, right? अब a plus b चाहिए, that means a square minus b square चाहिए. That means I want the squared quantity. That is why I went for squared quantity over here. That was the reason. Yeah, that's the beauty of it. I'm giving you 5 seconds again. You have to understand this proof with me. Take it 5 seconds. Done? Right. Now this quantity is nothing but Fn. So this is Fn into whatever these quantities are, definitely integers. Right? So this Fn minus 2 is equal to Fn into some quantity. I have related Fn and Fn directly. Right? Okay. Now, let me try to. मुझे तो d को 1 बताना था ना, अब बताते हैं. Cool. Now, d, since d is the greatest common divisor of these two quantities, can I say that d divides Fn? Right, greatest common divisor है, so d will divide it. Now, if d divides Fn, so d will divide Fn into some integer. Right? Okay. Now, since d divides some integer, now this thing is nothing but Fn minus 2. That means d should divide Fn minus 2. Right? Okay. Now I also know that d was the greatest common divisor of these two numbers. Right? That means d should divide this. D should divide Fn. Right? So d divides Fn. So d divides Fn minus 2. D divides Fn. That means d will divide difference of these two. D will divide Fn minus Fn minus 2. Difference of these two. So d will divide 2. D is such a number, such a positive natural number which divides 2. अब d की possible values क्या होती हैं? या तो d1 होगा और d will be 2. Right? Now tell me, do you think 2 can be d can be 2? D is greatest common divisor of these two numbers. ये 2 कैसे होगा? ये odd है, clearly. This is also odd. Greatest common divisor of two odd numbers will be odd only, right? 2 तो नहीं हो सकता, right? So B cannot be even. So B has to be 1. Greatest common divisor of Fn and Fn turns out to be 1. Right? If you take out any two arbitrary elements, their estimate is 1. That means those elements are pairwise co-prime to each other. Right? Now, truly, this was the most enjoyable proof. I think this is one of the few reasons that you actually study math. Many people say, ma'am, why do we study math? Because of this. So that you are able to understand the proof. Maybe not write it yourself at this time, but this is RMO level. But in order to understand this proof, that is why we study math. To appreciate the beauty of numbers. This is actual beauty. Right. So that's it for today's lecture. Now, Last time I told you that we need to do chapter 3 from mathematical circles, right? Hopefully you must have done it. If not, I am highly recommending you please do it. It is a brilliant chapter. Read the theory part of it and do each and every question. So I'm giving this question again because some of you haven't done it yet. So mathematical circles, divisibility and remainders chapter, brilliant chapter, and you should do it, right? Because the thing is, with these remainder type questions, if you don't practice, you will not get a hold of it. So please do it. You have to practice, right? So that's it. Thank you, and I will